as I said, when you have a point, when you have a point like this, subjected to different forces, as I said, F1, F2, whatever. The first thing that you have to do is finding the resultant force or summation. But because, as I said, each vector has both magnitude and and direction. You can say that, for example, we have a vector here. For example, the first one is the magnitude of the first one is 10 newton, second one is 15 newton, third one is 5 newton, and fourth one is 7, for example, newton. If I ask you what is the summation, you can say that the summation is 10 plus 7 plus 5 plus 15. You can say that. Why? Because they're acting in different directions. For example, in one of the obvious situations, suppose that you're pulling, for example, this is a rope, someone pulling from this side with the force of, for example, 10 kilonewton, the other one is pulling from the other side with the magnitude of, for example, 15 kilonewton. What is the total resultant or the final resultant of the force of acting on this rod? 10 plus 15 or 15 minus 10? Because they're acting in opposite directions, this is the final answer, not this one. So, as I said, because forces have direction, you can't just sum these magnitudes up. To find the summation of a force, a system of forces, three options. The first one is show it on the book. Before talking about this part, you know I think you know the forces and the units from the physics, yes? Newton, for example, pound, kilonewton, uh, kilopound, yes, or kips, centimeter, inches. You should know it, and I think you know it from the physics. And you have to know it how to convert this, because when I'm talking about forces, one of the important thing about a force is its units. For example, if you have two forces, one of them is 10 kilonewton, the other one is 5, for example, pound. You can't at first you have to convert one of them. For example, you have to convert pound into kilonewton, and then perform your calculation. You know it or not? Answer me.
Yes, teacher.
Okay. So the second chapter of the book, the first chapter is just introduction. In the second chapter, as I said, uh, you get familiar with the forces and their directions and their magnitude. Here you can see that this force has the magnitude of 10 pounds and the direction of 30 degree with respect to what? Horizontal direction. You can say you can just say that the force direction is 30 degree. You have to specify that this degree is with respect to what? In here, as I said, resultant of the forces. The first method is parallelogram. The second one is triangle method. And the last one and the most important one is uh, component method. In the first method, if we have two forces acting on a point, for example, we have force P and force Q. If I ask you to find the resultant of this system in the parallelogram method, at first, you have to draw a force, draw a vector. For example, parallel to Q from the end of the other one, like this. This is Q prime. And as I said, Q and Q prime are parallel with the same direction and with the same magnitude. But Q prime starts from the end of the P force. Also, you have to do it again. You have to draw another force like this, P prime. The P prime is parallel to P, but starts from the end of the Q. Okay, so the resultant is a vector that starts from here, ends with here, like this. This is your resultant. Okay, this is your resultant. As you saw, this method needs, for example, ruler. You need to draw something. That's why it's not very common, because it's complicated, and you can't use it for example, complicated cases when you have lots of forces, when you have different directions. It's not easy to perform, but it's very simple, and one of the first generation in finding the resultant. Okay, again, for example, we have a force like this and a force like this, P and Q. If I ask you to find the resultant, first, as I said, I need to draw a force parallel to P, like P prime. As I said, they are parallel and their magnitude are same and are equal. The second one is Q prime. Look at the direction. It is Q prime. And Q prime is parallel to Q. What would be the final answer? This is the resultant or summation. Okay. The second method is triangle method. Triangle method. In the triangle method, we have, for example, force P and force Q. The summation is a vector that starts from the first point and ends with the last point, like this. This is your summation. In the triangle method, it doesn't matter how many forces do you have. For example, many forces like this. As long as they follow this arrangement, that means one of them starts from the end of the other one in a row like this. The final summation is this. But for example, in these cases, you may face some problem like this. For example, this is your force P and this is your force Q. How are you going to use triangle method? Because as I said, this case, this arrangement doesn't follow this one. As I said, for example, look at here. In this case, we want to find the summation of P and Q. And as I said, this is our start point A, this is our vector P, and this is the other vector Q. As I said, the other one, Q, starts from the end of the first vector P. So we can just connect the first to the end. But in this case, we don't have such thing. We can't connect the end to the start to the end. So in these cases, we have to move the forces. Before moving any forces, you should know that you can move any force, okay? You can move a force if you keep the direction and the magnitude. What does it mean? That means, as I said, I need to find a situation, I need to find a condition that if I want to use triangle method, that the second force at the first point of the second force be at the end point of the other one. So in this case, I need to move the force. But as I said, when you are moving the force, you have to keep its direction and its magnitude. So if I want to keep the direction of force Q and put it here, I am allowed to do this. Okay, so I can, why? Because as you can see, Q and these forces, Q prime, are still parallel. And for example, if the magnitude of this force is 10, the other one is 10 too. Okay, so I'm allowed to do that, to do this. But I am not allowed to, for example, move the force in this way. Why? Because this one, the red one, the red one is not parallel to this one. So this is the wrong way. But as long as I as long as I keep the direction, so that's not gonna be any problem. So I'm gonna move this force Q in the way that I said. So the final situation, the is like this. Okay, I am not allowed to, for example, do this. As I said, this is parallel and the direction is, for example, from here to, for example, it's downward, but this one is upward. So I am not allowed to do this. Understood? Any problem, any question?
No, teacher, thank you. But teacher, I am Mustafa Abdullah. I am the first class today.
It's okay. I start from the beginning. From the yes, this is the first material.
Yes, teacher.
Okay. So, as I said, we can move the forces. For example, we have the opposite case. This is P and this is Q. If I ask you to use parallelogram method, what would you do? You should move the force from here.
From P to Q.
Yes, we have to do this. So we can use parallelogram. It's not complicated. You just need to focus that, and you'll find the answer. Do you know about sine rule and cosine rule? What are they? Sine rule and cosine. In a triangle, because one of our method is triangle method. Okay, in a triangle with this, for example, A, B, C are our edges, and angles are C, B, and A. Okay. In a triangle with these properties, we have two rules. The first one is sine rule. What is the sine rule? The sine rule says that sine of C divided by this one is equal to sine of B divided by front side. Sine of A is equal to A divided by A. All these ratios are equal. Okay, this is sine rule. We have another rule, cosine rule. What is cosine rule? This is the cosine rule. C squared is equal to A squared plus B squared minus 2AB cosine of C. So if I'm looking for this edge, and I have this one, and this one. So these parameters are known, but this one is unknown. I can use cosine rule. How it works? This one square plus this one square minus this one, that cosine of this angle. If I have, or if this one and this one is known, so I'm not gonna make it complicated and complex. So you can check the both of them and see which one is better to use. Okay, let's get back. Let me show you a couple of examples. For example, this one. I'm gonna solve this one. For example, we have a bolt here subjected to P and Q. One of them has the magnitude of 60 newton, the other one has the magnitude of 40 newton. And look at here, the direction of the force P, direction of the force P the direction of the force P is this 20, and the direction of Q is 45. Okay, so it is asked to what? Here, look at here. The two forces P and Q act on a boat A. Determine the resultant. Okay. As I said, we have two so far. We have two methods. The first one is parallelogram. Let's check if we can use parallelogram or not. The requirements for parallelogram is the first one is starting from the same point. So the forces, or let me say here in this way, the forces should start from same point. Look at here. So the first requirement is satisfied. The second one, when we want to use parallelogram, in the second one, we have to do what? We have to form or make a parallelogram. How? Look at here. I want to find the resultant. As I said, we need two forces starting from same point that's it's passed here. So the second part is forming or making a parallelogram like this. This force or this line, the green line, is parallel to this line. So I can name it P prime. The second one, I'm gonna make it with blue. The second one should again be parallel to Q, so I'm gonna name it Q prime. What would be the final summation? A vector that starts from here ends in here. So this is my resultant. If you are using this method, as I said, you have if you want to use this method, you have to use a ruler and the other things to, for example, to find the angles. So if I ask you what is the summation, in this case, you need to use your ruler, and if you draw these lines correctly, as I said, they should be parallel, exactly parallel, and with the same magnitude. So you just need to calculate or determine the length of this line and its direction. Okay, this is the direction, for example, angle alpha. And you can see that you can't use it in difficult cases, because you need to use ruler, you need to use something, and it's not applicable in many cases. I'm gonna find the summation with the second method, triangle method. So I'm gonna use triangle method again to find the summation. Okay. What is the first requirement of the triangle method? The first requirement, if you remember, I told you that the forces should be series. Okay, but in this case, they're not. So the first thing that I need to do is to rearrange this system. How? Like this. As I said, we have right now the system is like this. Okay, but I need to rearrange them in this way. As I said, I can move the forces if I keep their direction and their magnitude. So let's keep, for example, let's keep force P and move force Q. Okay, I'm gonna move the force Q here and keep the force P. So I'm gonna move the force Q to get the proper arrangement, like this. That was the first force, and this is the moved one. So this is our Q with the magnitude of 60 and the direction of 45. This direction is 20. What is the summation now? This is the summation. R. So far, we found the approximate direction and the approximate magnitude or length of this R. But it's not enough. If I ask you, for example, in your exam to find the summation, you should give me what? The magnitude and the direction. So right now we can use triangle method, and when we are using triangle method, we can use sine rule or cosine rule. How? Who knows what is this angle? This angle, alpha. How much is this? Do you have any idea? I'm gonna ask you. Wait.
I'm not sure, but 118?
118 or
Yeah.
118?
No, first one.
180 alpha? No.
Uh,
I think you all know that.
16, something like this, I think.
You know, in a triangle, you all know that A plus B plus C is what? 180.
Uh-huh.
Okay? And this line is 180. So this angle is what? 180 minus 45. What is the answer? 135.
135.
So this angle is 135. 135. Okay, this angle is 20. This angle is 135. In the other, in this triangle, we have such situation. One of the angles is 20, the other one is 135. What is this? $20. Yes, 25, sorry. 25. How? Because 20 plus 25 plus 135 would be 180. So this angle is 20. What is alpha right now? 180. This is 25. Minus 25 would be 155. Okay, so alpha is 155. This is the angle 155. This is force P, and this is Q. What is the magnitude of P for T? What is the magnitude of Q? 60. And what is the total magnitude, or R? If I ask you to find it, now you can easily find R by what? By cosine rule. How? P squared plus Q squared minus 2PQ dot cosine of what? This 155 would be R squared. So we have P. We have P 40 squared, 60 squared, minus 2.40.60 that cosine of 155. Everything is known. All we need is to find this answer, and the answer would be, for example, 97.7. But this is not enough. As I said, each force has two properties. One of them is magnitude, the other one is direction. What is the direction? If I want to find the direction, I have to use sine rule. In this angle, what is this? For example, this is theta, this is beta. Beta is 20, theta is unknown. Sine of theta divided by front edge for t is equal to sine of this angle divided by r is 97.7. So everything is known now. We can easily find sine of theta. And what is the theta at the end? This 15.04. So the theta is 15. Theta is I think you all know that. Theta is equal to sine inverse of 40 dot sine of 155 divided by r. It's equal to 15.4. So what is the total angle? Theta plus beta. Theta is 15, beta is 20, it's given. 35. Any question? If you have any question, you can have a look at this question and the solution. So you'll find your answer. Like here, as I said, you have to use cosine rule, then find r. We need to find this angle. To find this angle, we have to follow this, and this is your final answer. Any question?
No, teacher.
Okay. Okay, so see you next time.
Okay, teacher. Thank you. Have a good day.
Thank you. Bye.
Okay, teacher. Goodbye.
Yeah.